Hey guys, Mr. B here again, bringing another video. Uh, this one is going to be on a easy but tricky topic, if that makes sense. The limit of absolute value functions. So let's just start with a really easy example. So the limit as x goes to 0 from the left side of x, the absolute value of x over x. So this little symbol here, if you don't know what it means, is from the left side. Let me write that down. From the left side. So if I had 0 on a number line and 0 is right there, so from the left side means that it's approaching 0 from this side. So basically it's numbers that are a little bit negative and really close to 0. So when we think about the absolute value function, the absolute value function can be broken up into two pieces. So a piecewise function. So the first part being negative x and the second part being x. So if x is less than or equal to 0, we can have the absolute value function defined as negative x. And if it's positive, if x is greater than 0, it's just x. So let's see why that works. So let's pick a number. So first of all, if you don't know what an absolute value function does, it just makes everything positive. So like the absolute value of negative 4 is 4. The absolute value of 4 is 4. So if it's negative, it makes it positive. Is it positive? It stays positive. So if I pick a number that's less than 0, say 4, negative 4, so I have to go to this one because it's in that interval. So I go to negative 4, so it's negative 4. So it makes it 4. So this essentially acts like an absolute value function. It's almost like a sorting system. You pick a number, okay, negative 5. Okay, it's less than 0. We got to use this part. So negative 5 is positive 5. We have 6. Oh, that's greater than 0. We have to use this one. So therefore it's that. So how that applies to limits is that we have to think about which piece of this piecewise function we have for our limit. So because it's from the left side, we want to pick the part of the absolute value function that has those numbers in it. So this is this part, negative x. So where that comes in is we can change that absolute value symbol to this part right here, negative x over x. So what ends up happening is, of course, you get cancellation like you have in all your limit questions. So this cancels with this guy, and of course all I'm left with is negative 1. So the limit as this guy approaches left, or approaches 0 from the left side, is negative 1. So let's try the same thing from the right side. So limit as x approaches 0 from the right side. So the absolute value of x over x. So if it's from the right side of 0, so it's coming this way this time, so I'm going to pick the numbers that are greater than 0, so I'm going to pick just x. So I get the limit as x to 0 from the right side, x over x, and of course those just cancel. And then I'm left with just 1. So what we can see is that our one-sided limits actually approach different numbers. So this one approaches negative 1, this one approaches 1. So therefore, we can actually make a statement, which I wasn't really thinking about, but I will say it anyway, that as x approaches 0, and I'll say the absolute value of x over x does not exist. In order for a limit to exist, our one-sided limits have to approach the same number, which they don't in this case. Alright, well let's try a slightly different example. So let's try if we have this guy. So let's make it a little bit more complicated. Let's do the limit as x approaches 2 from the left side of x minus 2 all over x squared minus 4. So it's a little bit harder. I wouldn't classify this as a hard example. So again, these questions are all about whether you choose the right, I don't want to say the right side, the appropriate side of the absolute value function. So this guy can be broken up into two pieces, x minus 2, and then the negative of x minus 2. So I got this slightly backwards in the way I had put here, but that's all right. So this guy is going to be greater than 0. This guy is going to be less than or equal to 0. I should have had that reversed, but that's okay. No big deal. You guys get the point. So again, this is just a sorting function. So if that's not 0, it should be 2. And the reason why, of course, it's 2 is because we have this guy right here. This is basically your x-intercept of your linear function that's inside here. So we have to choose the appropriate side that we have. So since it's from the left side, that's less than or equal to 2, we have this guy. So we're going to take the negative version of this. So we have the limit as x goes to 2 from the left side. And then we have negative x minus 2 all over x squared minus 4. So now it's just about trying to get something to cancel. So I'll factor that difference of squares on the bottom. And if you're not still understanding about which side to choose, I'm going to give you a little tip for the end of this video. So we cancel, so I'm left with negative 1 over 2 plus 2, which is negative 1 over 4. So that's from the left side right there. So here's my rule. If I have a linear equation, linear abs value, so if I have a linear abs value, and it looks like this, I'll just rewrite this one, x minus 2. So if I have from the left side, I choose the negative, right side, I choose the positive. Now the only other scenario is if it's like this. So we have a negative slope. So then it's reversed. Right side, I choose the negative. Left side, I choose the positive. So the reason why that is, of course, is that if you look at an absolute value function, and this is the absolute value function for this guy, so the y-intercept's at 2, or x-intercept's at 2, it looks like this. But my original y, my original line is right here. So this is the piece of the graph that stays the same. So I always want to choose that guy to be like this, just the plus. Whereas with this one, it has a negative slope, and therefore it's going to look like, so my y-intercept is plus 2. It's going to look like this. So that's what my line looks like. So this is the original piece that stays the same in my absolute value. So this is the original piece of the line. So therefore, because it has a negative slope, I want to choose this as my plus. But it's going to be the opposite interval, so it's actually going to be the less than part. So let me just show you what I mean. So if I have the limit as x goes to, let me see, 2 negative, and instead of this time I have 2 minus x all over x squared minus 4. So in this scenario, it's very similar to this one. So it's left side. The only difference is I have a negative slope. So because I have a negative slope and it's left side, I want to choose the plus. If it was a positive slope, like it is in this case, from the left side, I want to choose a minus. So in this case, I just got to drop the absolute value, so 2 minus x, and x minus 2, x minus 2, x plus 2. So what I have here, and I'm just going to sort of scribble this out, it's factor of negative x minus 2, so I have that, cancel, cancel. So I actually end up with, again, negative 1 over 4. So you can kind of see, guys, that this little trick right here really helps you out. So let me just summarize that one more time, because I don't think I did a very good job of it. If this works for linear absolute value situations, so if you have a positive slope, so for something that has a positive slope, if it's approaching from the left side, you take the negative of your mx plus b. If it's from the right side, you take the positive of your mx plus b. If it's a negative slope, it's left side, you take the positive of mx plus b. If it's from the right side, you take the negative of mx plus b. So I really hope this helps, guys. I'm going to make another video after this with a couple more examples in it so you can see. So I thank you guys for watching. I really hope I did a decent job with this. Thank you very much, and I'll see you guys in class.